Hello guys, welcome to my YouTube channel, and today I'll be taking you on completing the square method of solving a quadratic equation. Without wasting much time, let's get started. If we have x squared plus 6x plus 9 equals to 0. If we have x squared plus 6x plus 9 equals to 0, and we have to solve this using completing the square methods, this is what we are going to do. The first step is to divide by the coefficient of x squared. Here the coefficient of x squared is 1, and the coefficient of x is 6, and here is a constant 9. So we divide all through by the coefficient of x squared. So dividing the terms by the coefficient of x squared, so there's divide each term by the coefficient of x squared. This over 1, this over 1, and this over 1, this over 1. So we will still have x squared plus 6x plus 9 equals to 0. Alright, now my second step is we take this positive 9 across this equality sign, and it will become negative 9. So you have something like x squared plus 6 equals to negative 9, because this positive 9, we take it across this equality sign and it will change to negative 9. Right? That is my second step. Now, so the next step is to take half of coefficient of x. Half of coefficient of x. And the coefficient of x here is 6. So we take half of 6, which is equals to 3. Square it and add it to both sides. So we have x squared plus 6x plus 3 squared equals to negative 9 plus 3 squared. So when we have something like this, look at the trick here. Open your bracket, you take x. This trick always works. It always works. It always works. So you take x, then you take this sign, which is your plus, then you take one of these 3 squared, so you take only 3, the 3 here, and squared everything, equals to negative 9 plus 9. So this is the trick. Let me remind you of the trick again. You take x plus, the plus is here, 3, which is this 3 here, then you squared everything, equals to this negative 9 plus 3 squared, which is 9. This trick always works for this factorization, because here we are actually factorizing this. So the trick always works, because there are some expressions that will need this kind of skills, because it will take time for you to actually do the factorization, right? So you take this and you take this and square everything, right? And take notice of the sign. So the next thing is we have our x plus 3 all in squared equals to 0, because negative 9 plus 9 is 0. What we need to do next is to eliminate this squared here. So we take square root to eliminate squared. So we have the square root of x plus 3 all in squared equals to the square root of 0. So we take the square root of both sides to eliminate this squared here. So this will cancel this. Let me use this. This square root will cancel this squared here. So we now have our x plus 3 equals to square root of 0. We have 0 So our x plus 3 equals to 0 and our x equals to, when this positive 3 crosses this equality sign, it will change to negative 3. So we have x equals to negative 3 twice. Let's take this other example. If you have 10x squared minus 11x minus 6 equals to 0. So let's solve this particular quadratic equation using completing the square. Alright, so the first step is to divide by the coefficient of x squared. So let's divide by the coefficient of x squared, and the coefficient of x squared here is 10. So let's divide by 10. Let's divide all these terms by 10. So we have here 10 will cancel 10. So we have x squared minus 11x all over 10 minus 6 all over 10 equals to, because 0 divided by 10 is 0, equals to 0. Alright, the next step is to take this across this equality sign, and it will change to positive 6 over 10. So you have something like this: x squared minus 11x all over 10 equals to 6 all over 10. So the next thing is by taking half of negative 11 all over 10. That is half of the coefficient of x, because the coefficient of x is this. So we are taking half of it. So which is like saying half times negative 11 all over 10, which is like saying negative 11 over 20, square it and add it to both sides. But when once we squared this, it's like also saying positive 11 over 20 all in squared, because this, when once it is squared, when this negative sign is being squared, it will change to positive. So this equals to this. Negative 11 over 20 all in squared is the same thing as saying positive 11 over 20 all in squared, because the negative, when it's being squared, it will change to what? Positive. So we have our x squared minus 11x all over 10 plus 11 all over 20 all in squared equals to 6 all over 10 plus 11 all over 20 all in squared. The reason why this positive sign is here is because here the negative, when it is being squared, it will change to what? Positive. So that's why this is plus 11 all over 20 all in what? Squared. All right, so going by that our trick, we will take this, which is our x, then we take this sign, this is our minus, then we take this 11 all over 20 all in squared. So this equals to, we have 6 all over 10 plus 11 squared is 121 all over 20 squared is 400, right? So let's continue here. So we have x minus 11 all over 20 all in squared equals to, the LCM of 10 and 400 is 400. So that is the LCM. LCM is 400, so we have 400 divided by 10, that is 40, and we have 40 times 6, 400 divided by 10, that is 40, 40 times 6, we have 240, plus 400 divided by 400, that is 1. 1 times 1 to 1, we have 1 to 1 here. So this equals to, we have x minus 11 all over 20 all in squared equals to 240 plus 121 is 361. 361 all over 400. So the next thing is to eliminate this square that is here. So we have our x minus 11 all over 20. We take square root of both sides, equals to 361 all over 400. So the square root will cancel this squared. So we have our x minus 11 all over 20 equals to square root of 361 is 19 all over square root of 400 is 20. So we have our x equals to, this is plus or minus, because we can have positive 19 over 20 or negative 19 over 20, right? So x equals to, when this negative 11 over 20 crosses this equality sign, it changes to positive. So we have x equals to, let's consider the positive plus or negative 19 over 20 plus 11 all over 20. So let's consider this positive first. You have x equals to 19 over 20 plus 11 all over 20. So since the denominators are the same, we take one of the denominators. So we have our x equals to 19 plus 11 all over 20, because the LCM is just 20. This 20, this 20, the LCM is 20. So we add the numerators, which equals to 30 all over 20. And when 0 cancels 0, which equals to 3 all over 2. That is one value of x. And x can also be, let's consider this negative sign here. So you have our negative 19 all over 20 plus 11 all over 20. So these are saying x equals to negative 19 plus 11 all over 20. So negative 19 plus 11 is essentially saying negative 8 all over 20, because the LCM is 20. That's why we take the denominators are 20 here and 20 here. That's why we take only the 20, because that is the LCM of 20 and 20. So negative 19 plus 11 is negative 8. Negative 8 over 20. If you divide through by 4, 4 goes into here, that is 2. That is negative 2, and 4 goes into here, that is 5. So you have equals to negative 2 all over what? 5. So we have our x equals to 3 over 2, and our x equals to negative 2 all over 5. Those are the two values of our x. All right. Let's consider this other example. We have x squared plus 5x plus 6 equals to 0. Let's solve this using completing the square. All right, the first step, let's divide by the coefficient of x squared, and the coefficient of x squared here is 1. So we still have this over 1, this over 1, this over 1, this over 1. So whatever we have, you have x squared plus 5x plus 6 equals to 0. So we divide by the coefficient of x squared and everything still remains the same. Now the next step is we take this positive 6 across this equality sign. So we have something like x squared plus 5x equals to, when this positive 6 crosses this equality sign, it will change to negative 6. Alright, the next step is to take half of the coefficient of x, and the coefficient of x is 5. So we take half of 5. Half of 5 is the same thing as saying 5 divided by 2, because here we have 1 over 2 times 5. They're saying 5 over 2. So half of coefficient of x, square it and add it to both sides. So we have something like this: x squared plus, sorry, let me rewrite it again. So you have x squared plus 5x plus 5 over 2, square it and add it to both sides. So we have negative 6 plus 5 over 2, all in squared. Then, going with that trick of factorization that I told you before, so this is what we are going to do here. We are going to take this x, then we take this sign, plus, then we take this particular 5 over 2 we have here, 5 over 2, then all in squared. So equals to, here we have negative 6 plus 5 over 2 all in squared is 5 squared all over 2 squared. So you have something like 25, because 5 squared is 25, divided by 2 squared is 4. So this is what we are going to have here. So the next thing is for us to simplify this. So we have our x plus 5 over 2 all in squared equals to, so we have negative 6 all over 1 plus 25 all over 4. So let's take the LCM. The LCM here is 4. So you have 4 divided by 1, that is 4. 4 times negative 6, we have negative 24, plus 4 divided by 4, 1. 1 times 25, we have our 25 here, equals to, we have x plus 5 all over 2 all in squared. So we have, let's continue here, we have x plus 5 all over 2 all in squared equals to, we have 1 all over 4. So we have, because negative 24 plus 25 is 1, so we have 1 all over 4. Right, so the next thing is for us to eliminate this squared that is here. So we take the square root of everything here. We have x plus 5 over 2 all in squared equals to square root of 1 all over 4. Okay, so the square root here will cancel this squared here. So we have our x plus 5 all over 2 equals to square root of 1 is 1 and the square root of 4 is 2. So we have our plus or minus. So our x equals to plus or minus 1 all over 2 minus 5 all over 2, right? So if we take this positive first, so we have our x equals to 1 all over 2 minus 5 all over 2. So since the denominators are equal, we have 2 here and 2 here, so our x, the first value of our x will be 1 minus 5. So we have negative 4 all over 2. When the denominators are the same, you take only one. So you have 2 here and 2 here. That's why we're having only 2, because the LCM here is 2. So you have x equals to negative 4 over 2, which is equals to negative 2. And let's take the other value of our x. So we have our x equals to negative 1 all over 2 minus 5 all over 2. So here our x equals to negative 1 minus 5, because the LCM here is still 2. We have our 2 here, so negative 1 minus 5 will be negative 6. So we have our x equals to negative 6 over 2. Then our x equals to negative 3. So the values of our x here are negative 2 and negative 3.